Okay, so today we are going to start with the alpha scattering experiment. So in alpha scattering experiment, you guys need to remember that the alpha emitter is placed within this chamber. It's basically an evacuated chamber. Okay, evacuated chamber means that it's just vacuum inside, so it doesn't strike anything else. Here, what you see right here, this is a gold foil, a very thin gold foil, right? So when the alpha particles are directed towards it, so they show three types of behavior, and we're gonna write that. Okay. So all right. So what happens is that the first what you see is this one. This is when the deflection is from 0 to 10 degrees, and the observation about this is that most of the alpha particles, almost all particles wait a second. All particles are undeflected or deflected at very small angles. Okay. Then you have deflection when it happens from the larger ones, which is like from 10 degrees to 90 degrees, which are these. Okay. Okay. So 10 degrees to 90 degrees. Some particles deflected at large angles. Okay. So out of 8,000, you might say they were like two or three, and then which means that there were very few which went out. Anyway, then you have 90 degrees to 180 degrees. Now, 90 degrees to 180 degrees, very few particles went backwards. Okay. And when you say very few particles went backwards, that means about one particle out of 8,000. Okay.
So can you scroll up for a second?
Yes. I just made this, nothing else.
Okay.
I don't know how. There's a problem going on. I have to manage many things right now. Wait a second, please. Okay, so now we're gonna look at some of the conclusions. Okay. Wait, let me just, Okay, Tania, you're here finally. Anyway, so those that went like completely straight, okay, those that went completely straight, that means that the conclusion is that almost all the atom is just empty space, which means that the atom has nothing here, right? So particles which like the particles went straight, or sometimes they got like if they were a bit closer to the nucleus, they would deflect a little. But usually they would go straight, and there's so much, the nucleus is so small and the atom is like so big that there's nothing really in the middle. Right? I hope you guys understand this. Any questions? Please let me know. Okay, then um, comes when the deflection is like very large. Then why is that? Because all the positive charge is concentrated at the center, which means that those particles which came directly in front of the like some particles that came really close to the nucleus had to be deflected at large angles because the nucleus is positive. All right. So this is how this makes sense in that way. Now, why is it that very few particles went back? Because the reason for that is that the all the mass, almost all parts, is concentrated in a very tiny. Now, writing tiny is the keyword. Tiny nucleus. Now, why do we have to put tiny the word there? Because 8,000 only like one could manage to come directly in the front. That is how it is small, and it was deflected back. Do you guys agree? Any questions? Please let me know. Now the
Sir, could you
drawing
please
I've
show
made
me
and everything that I've written, like zoom in. The drawing I made and everything I've written might be a part of your exam, so you have to remember this word by word, please. Okay. Now, the next thing is they're gonna give you some common values to remember. Like for example, the radius of proton and neutron, you guys need to remember, is 10 raised to a minus 15 meters. Radius of nucleus is 10 raised to minus 14 to 10 raised to minus 15 meters, and radius of atom is 10 raised to minus 10 meters. So, if you, by comparison, if you look at this, by comparison, like an atom is 40, like 100,000 times larger in radius. Okay. Compared to nucleus. So you guys need to remember that. Like it's very very big, and you guys need to remember because they might even ask you to calculate the volume, and if they ask you to calculate the volume, you just use the volume squared, but you have to know the radius anyway. All right.
So can you repeat this point?
Then should I explain it again?
Yes, sir.
So I'm saying if they say find the volume of, let's suppose, atom, okay? Now they will not give you the radius, so you have to remember what the radius is. You get my point?
Okay.
And you have to take atom uh, as a sphere. Okay.
Sir, is it 100,000
You get it?
nanometers?
100,000 nanometers. Yeah, 100,000 meters. I wrote 100,000 times actually. Okay. Any questions now? Let me know, please. Okay. Then we have to see the other things like Aman is here. No? Red mass and charge. So how do you do this? When you look at any element, it has two numbers. So this one is the nucleon number, which is also the mass number. Okay. And this is the atomic number, which is also known as proton number. So, which means that actually carbon has a mass of 12U, it's a relative mass, and charge is 6E. Now, what is this U and E? U is called unified atomic mass unit. It has a value 1.66 times 10 raised to minus 27 kilograms. We do this to manage the numbers. For charge, it is 1.6 times 10 raised to minus 19 coulombs. So you guys need to remember what is relative mass. These two values are already given in the exam in the data sheet. Okay, got to remember this. But if you do remember, obviously it's going to help you. It's not a bad thing to leave it. So now for carbon only, if I want to find the actual mass, what will I do? I will multiply 12 with 1.66 times 10 raised to minus 27. And that's going to be something like, I don't know, let me check. So carbon's actual 99 times 10 raised to power minus 26 kilograms. And the actual charge times 10 raised to minus 19. So that would be, is that clear, everyone? Will you be able to convert back and forth now? You guys can hear me, right?
Yes, sir.
God, that's so sad. Anyway, so then we're gonna move to the next, if you've written this. Okay. Now for this question, it says the results of alpha particle scattering experiment provide evidence for the structure of atom. Result one is that the vast majority of alpha particles pass straight through the metal foil are deviated by small angles. And then result two are very small minority of particles scattered through angle greater than 90 degree, which means they come back. What may be inferred or deduced from? Yes. So result 1, can somebody please tell me that?
Most of the atom is in empty space.
And result 2?
All the mass is concentrated in a very tiny nucleus.
All the mass and charge is centered in a tiny nucleus. So basically, when you write concentrated, like mass and charge, it means you'll get 1 mark, and for writing tiny nucleus, you'll get the other mark. Otherwise, you're going to lose it. All right. So don't forget, you have to rote learn all of this. Is it clear, everyone? Any questions now? Okay. Great. So going forward, this I'm going to give you as homework, so you guys can practice a bit. And then, which statement about alpha scattering experiment provides evidence for existence of the nucleus? Yes, please. What do you guys say? This is very simple.
Sir, I think it is A.
Obviously, it is A because the size of the nucleus stored by the third point, and that is when very few particles, like very tiny particle of proportion, just went back. You gotta remember that. Wajiha, Laiba, Khatijas, and Maham. Everybody understand this? Ayan, Dania, Ahmad,
Yes, sir.
Ryan, Umar, Yaya. Okay. Ayan. Okay, going to the next. This is again the same thing. It says, in the alpha scattering experiment, beam of alpha particles aimed at a thin foil. Most of the alpha particles go straight, are deflected by small angles. A very small proportion are deflected through more than 90 degrees, effectively rebounding towards the source of alpha particle. What conclusion about structure cannot be drawn? Yes, please. Which conclusion I never wrote about in the 3 points that I gave you?
Sir, I think it is B.
Most of the mass, I wrote it. Yes, right.
C.
It is C. Why it is C? Because it is one thing that has never been able to found. It never found about the neutrons. All right. So neutrons, I never wrote about the neutron. That means that it's C. Okay, remember that. Anyway, so now easiest thing in the world, the definition of an isotope. So when they ask you, which is obviously they will, right? So isotopes are atoms of the same element with different. Ryan, can you do? Can you call Munim and tell him to join, please? Number of neutrons, but same number of protons. Okay. Now, for example, like if you look at carbon, carbon has like the most stable one is 12, carbon 12, 6, but carbon has other isotopes like carbon 13, carbon 14. Carbon 14 is a radioactive isotope. So all of them have like same protons, but a different neutron number. Like it has 7, it has 8. You guys understand this? Now, so basically everything in the world is being driven or controlled by 4 fundamental forces which exist. Okay, the 4 fundamental forces are: number 1, gravitational force. It is the force between masses. Then you got electrostatic force, that is the force between charges. And then you have weak nuclear force, and we also call it interaction. Then you got strong nuclear force. Okay, so these two we're gonna learn in A2 hopefully very soon, and for the other ones you guys need to remember just this that I'm writing. Okay? So for weak nuclear interaction, you guys need to remember that this is responsible for beta particle emission. Okay, or decay, whatever you want, right? And strong nuclear force is it holds the nucleus together. And amongst all of this, amongst all other forces, this is the strongest. So magnitude wise, this has to be the strongest anyway. All right, please write this down, and then we're going to go forward. Okay. Then we got some of the features of alpha, beta, gamma radiations, and we also need to know their symbols, and we need to learn this table as well because they can ask you directly. So alpha has a couple of symbols, like alpha is A, okay, like this. Alpha is also written as 4,2. Alpha is also written as helium nucleus, okay. This is all alphas. Beta particles are like this, and gamma is like a ribbon, like this. The type is, this is helium nucleus. This is fast moving electron, and that is electromagnetic radiation. Now, relative mass of alpha is 4U. Beta has almost no mass, but we take it as 18 divided by 1 over 1840U, which is in reality 9.11 times 10 is to minus 31 kilogram, which is also the mass of electron. It has no rest mass. Relative charge is plus 2e. It has minus 1e, and obviously it has no charge as well, pure energy. So with respect to penetration, alpha has very low penetration, so can be stopped by thin paper. It has moderate penetration, which is it is stopped by aluminum. Okay, for British is aluminum. And then we have gamma. Gamma can be, gamma is very high penetration, and it is reduced by lead. Like, it cannot be fully stopped, but it's definitely reduced to a certain level by lead.
So what is the type
Then,
of alpha?
sorry,
The type of alpha. What is written there?
helium nucleus.
Okay.
About ionization, very high ionization for alpha, and the reason is because it has a +2 charge on it, so it can gain 2 electrons from anything in the surroundings. And beta has moderate ionization because it has -1 charge, and it can be a donor to something, right? So that's why this one has little to no ionization, and the reason is that it is like no charge on it. Now, speed in air, you guys need to remember this is up to 10 raised to power 6, and this is, I think, the most important thing. They might ask you this directly in the MCQ. This is up to 10 raised to power 8 meters per second, and that's basically 3.0 times 10 raised to 8 meters per second. That is speed of light. So this table you need to remember, please. Ryan, did you call him? Did you tell him to join? Okay. Now. Okay, Ryan. All right, should I move to the next thing now?
Can you just write this down later?
Also, wait, we'll write this down.
Okay.
Wait, so what about the range?
Oh, sorry, I forgot about the range. My bad. Sorry, please add one more point. Range, please. Okay. So the range, you can write few centimeter. Oh my god. Few centimeters. Few meters and unlimited range. When I say few centimeter, it is like 0 to 100. This is like 1 to 10 meters. And this is like unlimited. Is it clear? So they can ask you this as well. Interesting that I missed it. Okay. Thank you, Peter. Okay, go forward now. Everybody's written this. Okay. Now, the next question are very simple. So what do you guys say? Which rule describes the relative ionizing power? Alpha is? Go on, hurry up.
C.
Yeah, C. Alpha particle is not penetrating. It has to be most penetrating and most ionic. That's correct. Okay. Then we'll go to the electron volt. Okay. Now, electron volt is basically a unit of energy to manage very small numbers. Okay. Okay. So electron volt, you just need to remember 1 electron volt is equivalent to 1.6 times 10 raised to minus 19 joules. And I want to tell you that this value is not given in exam in data sheet. Okay, so you have to remember this because it corresponds to the charge of electron just in joules. So you guys need to remember. For example, if they say like convert 5.3 mega electron volts to joules. So how do you do this? You write 1 electron volt is 1.6 times 10 raised to minus 19 joules. So 5.3 mega electron volt means 5.3 times 10 raised to power 6 electron volt is equal to x. You're going to cross multiply. And obviously, that would basically be like you multiplying this value. And that would give you something like 8.5 times 10 raised to power minus 13 joules. Is it clear? So there could be other forms as well. The other forms are like, let me just write it here. KeV, MeV, GeV. So K, you know, this is kilo electron volt. This is mega electron volt. And this is giga electron volt. So I hope you guys will be able to understand when it comes, all right? Then it comes to fundamental particles, which is basically the main new thing for you. So there are two families of fundamental particles. They're like leptons and hadrons. Leptons and hadrons are characterized by their ability. Yes.
Little more.
Okay, so leptons do not feel strong nuclear force. And because they do not feel strong nuclear force, so obviously they will not be living in the nucleus. Do you understand? Hadrons feel strong nuclear force, and this is the reason they exist within the nucleus. Is it clear?
Yes.
So it means electrons are leptons and protons and neutrons are hadrons. Now then, they can be broken down into two subfamilies like mesons and baryons. So what is the difference? Whenever there is going to be a meson will consist of two quarks. I'm going to explain what quarks are. Quarks are fundamental particles. Number one normal quark will be there, and the other thing is that one anti-quark will be there. So they can be of various flavors or types is the same thing. All right. Then when it's going to be baryons consist of three quarks of any flavor or type. Okay. Flavor is just type. So when three quarks are made, they combine together, they make a baryon, and when one normal, one anti, that makes a meson. So you guys need to remember this. They're gonna ask this, all right? So both of them, basically are made from quarks, which are the fundamental particles. I hope you guys understand this. So when I'm going to talk about particles and antiparticles, what I mean by this is, let's suppose there is one person, looks like this, okay, and there's another person, a copy of that. So they look like the same, their physical features are the same, but they can be anti to each other. Like if this one person is like a particle, the other thing is like an antiparticle. And so they have same physical properties, but they have opposite chemical properties, which means that they will have opposite charge but same mass and color and everything else. I hope you guys understand the difference, okay? Okay. Any questions, please?
No, sir.
Okay, going to the next. So although there are like 12 fundamental particles, but in our course there are only 2 leptons that we need to remember. First lepton is an electron. The electron symbol is E and minus. The mass of electron, like I said, it's 9.11 times 10 raised to minus 31 kilograms. Charge is negative 1 e. Then you have electron neutrino. Symbol is VE. Some people just like to write V because there's one only. There is almost no mass. It has a mass, but very less than electrons 1. No charge. When we talk about the antiparticle, so electron antiparticle is called positron. Positron. The symbol of positron is E plus, and it has the same mass and opposite charge, so it has plus 1 E. And then for an anti-particle of electron neutrino, we write anti-electron neutrino, and it is like VE, and you will have dash on top of it. Dash means that it is an antiparticle. So almost no mass and no charge. You guys get it? Please fill in the table. Okay then. Now going to the next, we're going to talk about quarks and anti-quarks. So first of all, we have names like this, right? Up, down, top, bottom, charm, and strange. The symbol of up is U, small d, small t, small b, small c, small s. Like the mass of every one of them is 1 by 3U. U, just remember, is the relative mass. You already know how to convert it to kgs. And the charge of up is 2 plus 2 by 3e. It is negative 1 by 3e plus 2 by 3e, negative 1 by 3e plus 2 by 3e, negative 1 by 3e. Okay. Then you have anti-up, anti-down, anti-top, anti-bottom, anti-charm, and anti-strange. So these would be the antiparticles. The symbols are U dash, D dash. Dash basically tells you that it's an antiparticle. B dash, C dash, S dash. The mass, because physical properties stay the same, so mass would be the same, 1 by 3 of all of them, 1 by 3U. And the charge would be now opposite as well, negative 2 by 3E plus 1 by 3E, negative 2 by 3E plus 1 by 3E, negative 2 by 3E plus 1 by 3. So opposite charge, same mass. Everybody understand this? Any questions?
Yes.
Okay. Now, obviously, you need to remember all of this, and you might be thinking, how would I do that? So I made this, way to remember this myself. So we already know whenever we create a graph, we know that we take this side as positive. Oh my god, that's not fair. Okay. We take this side as positive, so write like plus 2 by 3e on a small graph. You can make it yourself as well. And negative 1 by 3e like this, okay? Now, within these names, right, so we're going to use some English here. So, up, top, and charm, they're all positive sounding words. And because they're positive sounding words, it means I will remember they have this charge. Is it clear? And if there's an antiparticle, I'll just put a minus sign. Is it clear?
Yes.
And if you look at the other three, down, bottom, and strange, they're all negative sounding words. So I've remembered that they're negative 1 by 3, like that. So I don't need to, ratify anything here. Okay. You guys get it? And obviously all of them have the same mass, which is 1 by 3u. That you guys need to remember. Do you still have 20 minutes to finish this? Let's do it quickly because I need to leave these 15 minutes early because of Ramadan. Okay, done. Should I go to the next slide, please?
Yeah.
Oh my god, I'm sick. That's not good.
Sir, before that, can you just go up? Take a photo.
Yes, please. There you go. This way. Quarks. Or leptons.
Above that. Anti-electron.
Can you see everything?
Yeah. Okay, thank you.
Okay. So, going to the next, all right? So then you have like core composition of proton and neutron. You need to remember this. For proton, it is U, U, and D. For neutron, it is U, D, D. So it's basically made from three. Can I ask you which family do they belong to? Yes, please. What is the name of the family that has three quarks of any flavor? Can somebody please help that? I think you guys know.
Hadron.
No, hadron is the bigger family.
Baryons.
Subfamilies. Baryons. They're both baryons, right? Because they're three. So first of all, you want to check the mass if it corresponds to a proton mass. So UUD means 1 by 3U plus 1 by 3U plus 1 by 3U. So this is going to be 3 by 3U. That's 1 U mass. And now let's check the charge. Plus 2 by 3E plus 2 by 3E, right? And negative 1 by 3E. That comes to be plus 1E. So proton has one charge and one mass. Do you guys understand this? Now for the neutron, the mass is going to be 1 by 3U plus 1 by 3U plus 1 by 3U, and that's going to be 1U. And for the charge, we're going to check like plus 2 by 3E minus 1 by 3E minus 1 by 3E, so it's going to be 0. So obviously neutron has no one mass, no charge. You guys get it? How I checked it?
So how did you get UUD or UDD?
Sorry, come again?
How did you get like UDD for this?
This is fixed. This is fixed.
Okay.
This is a fact. Okay, we can't change that. We just need to remember that this is the composition of neutron proton. Other particles may have different. They might have strange stop, whatever. But these two have this fixed composition. Okay. तारीख की बात नहीं Okay, done. Now, you guys need to remember this is very essential. They will ask you directly again. I'll show you some questions. Anyway, then you guys need to remember in physics there has to be 4 fundamental laws that needs to be followed if you're supposed to, if you want them to work. Okay. So the 4 fundamental laws are: number 1, conservation of mass energy, and that's Einstein's relative equation, E equals to mc squared. The second law that must be followed is conservation of charge. All right, so total charge before and after equation should be same. Third conservation is conservation of number of particles. So the total number of particles before and after should be the same. You cannot just lose a particle. And obviously the conservation of momentum. So these four laws must be obeyed in any equation, and if they are not obeyed in a certain equation, that means that equation will not be correct or that cannot be possible. Okay, so you can write this, and then we have to do two equations, and then our syllabus will be finished. Okay then, done. Should I go forward? Now this chapter, I just want to tell you, this is like very few numericals, but you need to remember a lot of facts. So it's better that if you start, rote learning it. There's no other way to do it. Anyway, so then going to this. Now it says, like for example, this question. It says, which row gives quark composition of neutron and proton? Can you please tell me? And which force that give rise to this reaction? Yes, please. Neutron is DDU, D up, and strong interaction with strong nuclear force. So that has to be the right answer. Is it clear? So this is like a fact, and you just need to do it, and it will only take like 1 second for you in the exam. So you can focus on other MCQs which are longer. All right. Then, so first equation we're going to do is the beta negative, and first of all we're going to look at its atomic equation, atomic level equation. So this can be any equation they can give you, but I'm teaching you with one equation, which is carbon 14 6. This is an isotope. Goes into nitrogen 14 7 plus beta negative plus an anti-electron neutrino. Okay, so this is the equation. Now, in this equation, if you look at this, like if you want to check, Balki we'll do it at that. So in this equation, you might realize that actually you have 6 protons and you had 8 neutrons initially, which basically converted to 7 protons and 7 neutrons, 1 electron, okay, that is negative, 1 electron and an anti-electron neutrino, okay. If you notice that basically in the subatomic level, what has changed? There was 1 neutron that has converted to 1 proton, and it has given this. Do you guys agree?
Yeah.
Right. So let me just change the color. This is not what I wanted it to be. Okay. Now, remember that this equation, like this equation, can be directly asked from you. Okay. So, but remember this. So you can just see from that. Then, when you go to the fundamental level, fundamental equation of this is that a neutron has a composition of, who's going to tell me the composition of neutron, please? Neutron is
Up, down.
Up, down, down. Proton is? Go on.
Up, down.
Up, down, plus an electron, plus anti-electron neutrino. And if you look at the equation now carefully, you might realize that actually this equation has up, down here, up, down here. So it means a down quark has changed to up. It has given an electron and an anti-electron neutrino, like that. Okay, so this equation needs to be learned as well. So we need to understand that whenever in any equation you have a lepton released, with the lepton, you will always see an anti-lepton released. Is that clear, everyone? Now, in order to
Yes.
check whether the equation is correct or not, so we have to check their mass and charge. Okay. So I'm going to use a different color. Let me use what color should I use? I don't know. Okay, I'll use this color anyway. So for the mass, I would be like 14U equals to 14U plus 0 plus 0. So mass on both sides is the same. So before and after it's the same. So conserve. Charge plus 6E plus 7E negative 1E plus 0. So 6 and 6 on both sides. So this is also conserved. Is it clear? So it means this equation is correct. Then for this one, let's check the mass. So neutron has 1, like neutron can be written as 1 0, charge 1 1 1. Uh-oh. 1 1. You can write uh-oh. It's not good. 1 1. Okay. So one mass, no mass, no mass. So 1 and 1 conserve. Charge is 0. This is 1E. This is negative 1E plus 0. So 0 0 conserve. Do you guys agree? So this is the same way if they ask you to prove it, you have to prove it this way, okay? Then for a fundamental one, what is the what is the mass of down quark? Tell me please. All quarks have same mass, you guys know. And what is that?
1 by 3.
1 by 3. 1 by 3U equals to 1 by 3U plus 0 plus 0. So both have the same mass, correct? And then for the charge, you're going to prove that it is negative 2 by 3, sorry, negative 1 by 3 E. This is positive 2 by 3 minus 1 E plus 0. So if you use this, it will be negative 1 by 3. This is also conserved on both sides. Is it clear? Any questions? Now again, we have beta positive equation as well. So what to do? First, we're going to look at the atomic equation. For atomic equation, it's basically when nitrogen 13 goes to carbon 13 6, it gives a positron, which is positive particle of electron, right, and normal neutrino. So then, if you look at this equation carefully, you realize that it has 7 protons and 6 neutrons, and it has 6 protons and 7 neutrons. And then it gives you a positron, 0 plus 1, right? Positron is the antiparticle of electron. And it gives you a normal neutrino. So basically, in subatomic level, it means that it has changed to 1 proton has gone into 1 neutron plus a positron plus a normal neutrino. Is that clear, everyone? So this equation needs to be remembered. If you don't know how to do this, then just remember this, the matter. Then we're going to look at the fundamental equation. In the fundamental equation, what is the composition of proton? Who's going to tell me that?
UUD.
UUD goes to? Yes, next.
UDD.
UDD plus a positron plus a normal neutrino. So you see it has UD here, it has UD here. So it means the change that has occurred is when up quark has changed to down, plus it has given a positron plus a neutrino, like that. Now we're gonna check whether they're correct. Okay. So for the mass, it is 13 U equals to 13 U plus 0 plus 0. So it's conserved. For the charge, it is plus 7E. It is plus 6E plus 1E plus 0. So it is 7 and 7 charge is conserved as well. For the second one, proton has a mass of 1U equals to 1U plus 0 plus 0 conserved. For the charge, it's going to be plus 1E. This is 0. This is plus 1E. This is 0. So 1E and 1E is correct. Okay. For the next one, mass. Who's going to tell me the mass of a quark? Yes, guys. Mass of a quark is? That's not fair.
1 by 3.
1 by 3. 1 by 3U equals to 1 by 3U plus 0 plus 0. So that's correct. And for the charge, it's going to be up is plus 2 by 3E. Down is negative 1 by 3E. And this is 1E. And this is 0. So negative 1 by 3 and 1 is like 2 by 3. So this is also correct. You guys get it? Any questions now? So nothing more than this will ever come in an exam. Now, you can write this down and then we just answer 2 questions. Well, that's very strange. Okay then. So then let's suppose this one. There is a question. It says a sample of isotope emits beta negative, which is. Oh, by the way, I just want to tell you one more thing. If you look at this equation, you see the same thing has happened here. You had an anti-lepton. And with an anti-lepton, a normal lepton has been released. So always with an anti-particle, there will be a particle with respect to lepton. So you guys got to remember that. In the previous equation, it was lepton released, so anti-lepton was released with it. Now there's an anti-lepton, so lepton released. Do you guys agree?
Yeah.
Okay, I hope you guys will remember this, okay? All right. Then we're going to go to this question, which says a sample of isotope beta negative particles. The emitted beta negative particle has a range of energies. Okay, so what must be emitted with beta negative? What is released? This is a normal lepton, right? So anti-neutrino. That is correct. Very good. Then what is the value of P and Q? So you need to check mass and charge again. So this is the same thing over. Then the same thing. Now in this equation, like if you don't remember what's this, then you will be pretty much, stuck in this. But even if you remember that beta negative is like 0 and -1 and anti-electron neutrino 0 and 0, you can find it. Like, it's basically charge will be, the mass will be 1 and charge has to be 1 to make it 0. So it has to be proton. So, or you remember this. State the name of particle represented by this. Can somebody please tell me the name of particle? What's that?
Anti-neutrino.
Anti-neutrino. Very good. It's very easy. State the name of the class group particles that belong to this. What is that class? What is that family? No. That's incorrect.
Leptons.
Leptons. Very good. Then state the quark structure of neutron. Who's going to tell me that?
UDD.
Very good. The change to the quark structure when neutron decays. What happens to neutron? When a neutron decays, what happens to the quark structure then? Which equation is this? No, that is when it decays. A neutron goes to, it is UDD. This is goes to proton. That is UUD. So what is the change?
Electron to proton. From neutron to proton.
No. A down quark changes to an up quark. Do you guys understand this?
Yes.
If you don't remember this, if you don't rote learn this, you're gonna fail in this. So please do not leave this chapter. It has 100% question at the end and in the MCQ paper as well. Now it says a nucleus of sodium-21 decays to form a new nucleus containing 10 protons, 11 neutrons. Which leptons are emitted? Yes. So Na21 goes to what? Some particle that has 10 protons and 11 neutrons. That means this one. So what else is released? They ask you this, okay? So if you look at this, this is like a proton has been converted to a neutron. You guys agree? So whenever a proton is converted, what is released then?
Anti-neutrino.
A beta positive particle with proton and you get it? Okay. A neutron decays to a proton. Which particle is not involved? Yes. Now this is an equation of when down. Oh, well, I'll just say when neutron goes to a proton, it is always accompanied by an electron and anti-electron neutrino. You understand? So positron is not released. Is it clear? Now, if you don't remember this, obviously, if you don't remember the equations, you won't be able to do it. Like neutron goes to proton, electron. You get it? So please remember this. This is very important. Then all the rest of the particles are very similar. I want to do this question and then I'll give you the rest of this homework. Okay. So now in this one, it says state the name of particles in that list that are not fundamental. Which particles are not fundamental in this list? Please go on. Hurry up.
Neutron and proton.
Alpha particle is also not fundamental. Okay, and then do not experience electric force when situated in electric field. Which one?
Neutron.
Neutron, it has no charge. Okay. Has the largest ratio charge. What is the largest ratio? Alpha particle is 4 to beta particle has almost no mass and positive 1 charge. Neutron has no charge, 1 mass. Proton has 1 charge, 1 mass. Now let's check. For alpha, it's going to be charge to mass ratio will be 2/4, which is half. For let me write it here, half. This will be 0/1, that is infinity. That is going to be 1 over 0. Sorry, this is 1 over 0. This is 0 over 1, that is 0. And that is 1 over 1, that is 1. So this means this one have the largest one. So we're going to write beta plus. Is it clear, everyone? Now, the last question for today. It says the hadron has a charge of E, where E is the elementary charge. The hadron is composed of only 2 quarks. one of these quarks is an anti-down. By considering charge, state and explain the name, flavor of other quark, right? So which is a hadron with only 2 quarks and 1 anti-normal? That is a which family is that? Hurry up, hurry up, hurry up. Meson. Meson. You guys forgot already. Anyway, so now it says you want to have plus E. Anti-down is plus 1 by 3E. What should I add to it so it becomes 1E? We got to be any type of U, top, or charm. Anything you can write. Okay, so this will be plus 2 by 3E. That's going to give you 1E, and it belongs to Meson. 1 up and 1 anti-down. This is what will give you basically 3 marks. Now, rest of the questions, all of them are homeworks because there's nothing different about it. Please do this, and you will also just okay. I'm just writing this one, and then we are done. Why beta particles get released? Due to weak nuclear force. If they ask you, you just write that. Why do particles have range of energies? Because they also share their kinetic energies with other particles formed in the decay. So you guys need to remember that as well, all right? And that's it. Rest of the questions are all homework. So your syllabus is finished, and inshallah, from Monday we'll start past papers. I'll send you the PDF for that too, so you can print it beforehand. Okay, bye.
Assalamu alaikum, sir.
Wa alaikum salam.